Hello everyone, welcome to the demo. This is the entire architecture of Cosmic Talent application that I have submitted for this hackathon. We have three processes involved in this architecture. The first one is the document intelligence process, where we have some of the resume documents that we have within the organization. We labeled them and we made use of custom extraction model to extract the information from these documents, which is then used in the further stages of our application. The next phase is where the user will be uploading the resume, which initiates the process of resume upload process. So it will reach to the Azure Function app, which is containerized and hosted in the Azure Container App environment. So this Azure Function app process this document and places it in the storage account, and also it will fetch the relevant information from the document with the help of custom extraction model that we created from our previous process. So now it has all the information which will be then placed onto the service bus. So from here, the worker service will keep on listening to the service bus, and whenever a message has been placed onto the service bus, it will pick up those and it will start to process the JSON output that we receive from the document intelligence service. So what this worker service does is it will get the JSON output from the Azure Document Intelligence, which has been placed in the service bus, and then it will create chunks of those fields, which will be then vectorized using the test embedding ADA model that we have in the Azure OpenAI service. And in case of project level details, we also do one more level of summarization, and then it will proceed to the vectorization stage. So once we have created those chunks of documents, it will be then stored into the Azure Cosmos DB. So now the third process kicks in. So whenever an HR or a manager who is using this application who prompts us with a query, so it and then it sends a request to the talent processor. So this talent processor is responsible to convert the query into a vector embedding so that we will be able to match the semantically related documents in our Cosmos DB. This happens through the test embedding ADA model. So the query will be vectorized using this model, and then it will be sent to the vector search function, which will try to retrieve the informations which are semantically matched with the query. And finally, the response will be sent back to the Copilot. To explain the RAG process that we have in this application, let's consider the output of the Azure Document Intelligence is these different fields. Improvise the RAG. What we did is we divided this entire document into chunks of documents. Each chunks will be having specific information about the employee, like the ID and the name, along all the chunks, so that the context is not missed over the chunks. And we can either have the combination of fields or the individual fields as separate chunks. So these level of control we will be having with the chunking pattern that we have followed in this application. And also specifically, if it is going to be a project level detail, we will do a summarization on top of it, and then we will be sending it to the vectorization. Finally, these vector embeddings are stored into the Azure Cosmos DB. This is the deployed version of our application. Just to show a difference how our RAG pattern provides us the better result, I will just cover few of the initial versions that we have considered. So in the initial version, what we did is like we stored the vector embeddings of the entire document into a single collection, and then we did some queries on top of it. So the first thing that we noticed is the prompt token. So the prompt token that has been utilized was exceeding the token limits that we had, because of which it was not able to give us a proper answer. And the next problem that we faced is like it was not able to fetch other employee information because of the same reason of the token limit exceedation. So that is where like we have refined those RAG pattern. Once we did this, like we have seen a tremendous improvement in the retrieval. So when we asked about the employee detail, which is the similar question that we asked in the initial version, so it was able to provide us a response back with number of token consumed lesser than the initial version, and also a better result compared to the previous version. And when we asked about other employee details, it was also able to fetch the detail now, because now we have the chunk of those documents and it was able to retrieve effectively. So now we tried to provide with some of the job description, and we asked like who will be fitting a better for this particular job description, and it was able to accurately point out few of the employees that we had uploaded with the Azure experience.